Now I want to try taking the derivative of this composition, secant of e to the square root of x. Seeing a square root, I'm going to immediately rewrite that as a fractional power. And here I notice that there are actually three functions involved. I'm taking the square root, or the fractional power, I'm plugging that into the exponential function, and then I'm plugging that into secant. And all of this is function composition. I only see one x here. I'm not multiplying secant and the exponential function. I'm plugging that in to the secant. Okay, so we're going to be using chain rule. We're just going to have to use it more than once. Okay. If you've been using the U substitution method, that can be very nice for smaller problems. I find that it starts to get unwieldy if I have too many pieces and too much going on. So I'm going to try to work this one out without using that U notation, although you're welcome to use it. I just personally find that it starts to get unwieldy when the problem gets too big. Okay. So if we were evaluating this, we'd work from the inside out. We take the square root, then we'd exponentiate, then we take secant. When we're taking the derivative, we work from the outside in. So I would say let's take the derivative of secant. The derivative of secant of something is secant of that thing times tangent of that thing. And what was that thing? What were we plugging into secant? E to the x to the 1/2. Or e to the square root of x, however you want to write it. I'm just going to keep it as x to the 1/2. That's the derivative of the secant part times the derivative of e to the x to the 1/2. So now I need to go back and evaluate my d by dx here. Now, just to save some time, I'm just going to indicate that I would copy that first factor. Actually, it's two factors, but that's that first derivative of secant. And now I'm taking the derivative here. The derivative of e to the something is e to the something. And that something was x to the 1/2 times the derivative of the inside part. So times the derivative of x to the 1/2. Okay. So now I need to evaluate this derivative. I still have that first derivative. I still have the e to the x to the 1/2. Now I'm also going to have a 1/2 x to the negative 1/2. Now I'm going to write out my final answer up at the top. It's this first derivative that we got, secant of e raised to the x to the 1/2 times tangent of e to the x to the 1/2 times e to the x to the 1/2 times 1/2 x to the negative 1/2. Essentially, I can say this was the derivative of the third function, that was the derivative of the middle one, and that was the derivative of the third one. Now, I would want you to turn in your final answer neatly written out, not sort of circled like this. But it's kind of neat to see what's happening. We end up with the product of 1, 2, 3 pieces. That's the three derivatives of the three functions that were involved in this composition. Okay. Probably the only simplification that I would do is I might just bump. I usually like to have the constant factor at the beginning, so I might move that 1/2 to the very front. That's totally optional, but probably what I would do.